Good afternoon, everybody. Welcome to class today. Thank you for joining me. Whether you're watching live or you're watching the recording, I just appreciate you watching. And so today, for the first time in a few weeks here, we actually get to start a new module, which I think is pretty cool. Right? You can start a new module, get to start something new, right? We get to move on to something a little bit different. And I think in moving on to something just a little bit different here, I think, in my opinion, right, this is a little bit easier than what we were doing in the previous module. You know, a lot of people like to do this kind of in reverse. I kind of like it the way that we do it just a little bit better, though, just because I think it gives us more time to kind of spend on what I consider to be the harder stuff. Right? Because I think we are entering in, you know, kind of with the, you know, some of the easier stuff now. Like when we get into the next module and we talk about normalization, the actual normalization process is super easy, even though the theory surrounding it is more complex. Right? And I think I think this might be the easiest module in the entire course, maybe. Right, in terms of what you're being asked to do or asked to create in manipulating databases. Because what we're actually doing is changing the data, manipulating the data, updating the data, adding new data, taking data away, creating tables, removing tables, all that sort of stuff. Right, and so before we get started today, just a couple of quick reminders. One is that registration for spring for returning students opens up today. Right, so if you need to get registered for spring, that opens up today. You probably want to go ahead and get on that as quickly as possible, just so you make sure that you get what you need. Right, we'll kind of be closing classes if they don't meet required enrollment. So if the earlier you get into them, the more likely it is you'll be able to take that course. It'll be able to run, right? So you won't have to worry about it. So go ahead and sign up early instead of waiting if you are able. Also, I don't normally announce events, but Fall Fest is this coming Thursday. If you'd like to come by, have a little fun at Fall Fest. It is from 5 to 7:30 out here in the Advanced Technology Center courtyard between the ATC and the Paxway building. Just to have a little bit of, have a little bit of fall fun there. You're welcome to come check that out. See what's going on there for that. Got a lot of exciting things going on there. So, make sure that you're checking your student email for all the exciting stuff that's going on campus there. Lots of cool stuff going on as we get up toward the end of the semester. We're talking about manipulating databases, and as we're talking about manipulating databases, there is one thing that's going to be kind of important for us to note, and that is this idea that the changes that we're going to be making to the databases are going to be permanent. Right? So if we mess up and we make mistakes, it's not like the last module where, if we just mess up and we make a little mistake, then it's fine. We just change our query a little bit and, no big deal. In this module, if we mess up and we make a mistake, then really we've broken our table. right? And so that's a big thing. So I just wanted to kind of point something out to you as you're getting ready to do assignments here. And that is, in your assignments, you'll notice I have some links to some text files here. It's the same text file in the instructions to both of these assignments here. The replace and populate tennis tables. When we click those, it shows us all this code here. This just resets. This is the code that will reset all of the tables that are in our sample database that we're using so far back to the way they are now. So if you make some mistakes while you're running code or while you're working with code in these modules, you'll want to make sure that you reset the database to get it back to where it is now. You just copy all of these commands out of here, and you would just paste it into MySQL Workbench, run everything, and that's going to reset all the code back to where it is currently at the end of the previous module. Right? Because as we are deleting and removing things from the database, or as we're adding things to a database, the changes that we are making are going to be permanent. Right? There's no sort of Control-Z undo button when we drop a table, for example. Right? Like when we drop a table, table's gone. So we want to make sure that we are kind of being mindful of what we're doing here as we are approaching this module. But in terms of how we're approaching the content from this module over the course of the next few weeks, we're basically going to be doing it the exact same way that we were. I really have to start to remember to hide that scene when it's over. We're going to be approaching it basically the exact same way that we were approaching the previous module, where we'll be looking at just a few things each week, breaking them down to where we're not doing so much at a time. So we'll be looking at a few things this week, a few things next week, on up until, let's see, when is this module over? November the 10th. So we've got this week, next week, and then one more week, I think, of live classes for this module. Although 1 week, I think, might be pre-recorded out of those 3, because I think there might be something else going on campus one of those days that I will have to be gone for. I will not be able to live stream for. So one of those might be pre-recorded, but the rest we'll do live. And so we'll just break them down. We'll do about, I've got roughly 30 slides in my slide deck, so that means roughly 10 slides a week that we'll have a look at, and we'll just do a little bit from here and there and just adjust and do what we need to do every week until we cover all of this material for Module 4. Got way too many windows open trying to find the right one. So first of all, let's go back in time just a little bit, and let's talk about Module 3. The previous module that we were working on, and talk about kind of what we've done so far, which is basically retrieval queries. Right? One of the things that we've said in the past is essentially what we're doing here is we're kind of ordering off the menu, right? We're kind of given a menu. When we look at our database is kind of acting like our menu. And we can either order, very vaguely, order very generically, and kind of, get our waiter to bring us back all sorts of different stuff from our database, or we can order very specifically and get a very specific dish brought back to us. And that's kind of been the culmination of what we've been doing over the last several weeks. Right, and these are our record retrieving queries that we've been doing in Module 3. And over the course of the live classes for those several weeks, we kind of started out with these really vague queries, and as we progressed, we got more and more and more and more specific until we were, being able to pinpoint very specific queries from our database, the kinds of things that you all, were kind of working with in your lab assignments that were due last Thursday. Some of these things were quite complex, right? And so, we had all the pieces and all the parts. It was all just about, trying to fit them all together and put them in the right order to figure out, what it took to get the right answer to our queries or to our questions that we needed answers to. And so it's this sort of math equation of being able to say, well, okay, I need to find out how to put things in order to get these specific results for this question. But then as we kind of talk about data, we understand that data isn't stagnant, that data changes. And data changes over time, and data changes within different contexts, right? One of the things that we've all been kind of plagued with lately is this idea that, for example, prices change. And prices are in a database somewhere, right? Inflation or, whatever sort of issues that are kind of plaguing us when it comes to things changing. Right, and so we need to be able to go in and update data when data needs to be updated. Because data isn't forever. Data does change, and we want to make sure that we have that flexibility and that ability to make sure our data is as flexible, or make sure that any applications that we're writing or any records that we're using to retrieve our data are as flexible as the data that we are, retrieving. So what exactly do we do when data changes? And the first big thing that we talk about is, we talk about creating a new table. Right, so our problem is that we want to create a new table. Let's think for a minute about one of those common things that we face in sort of data management, data analysis, is this idea that we want to keep new records. And it's something that we'll kind of get in depth in when we get into Module 5, right? We talk about the idea of normalization. But we can even just kind of look at it from a different perspective now with this idea that, we start out small. We start out maybe collecting just a little bit of data. Or we start out with a very simple database to where, if we don't have a lot of records to keep, then it doesn't really matter how we keep them as much because, our database is very simple. We don't, have a lot of data stored in it, so we can, query it quickly and easily. But as our data sets grow, or as our customer bases grow, or as the services that we provide maybe grows, and we start to need to collect more data from our customer base, or we have a larger set of data that we're getting from customers, then we need to add more tables and populate more tables based on these different aspects of data that we're now collecting. Or maybe we've decided that, where we weren't normalizing data before, now we should be normalizing data. And again, we'll talk more about what that means in the next module. And so one of the most common things that we'll want to do is be able to create a table to put our new data in. So we've got this database, and we're going to want to put some new table in our database to hold some new data. And it is fairly simple, although it does require a lot of different components in order to complete the query. So what I'd like to do is I'd like to kind of look at these different little components and then go over a little sample query where we kind of put them all together. Right, and so we'll kind of break it down and look at different components and examine things that way. Because we've kind of talked about previously, we've talked about the structure of our database. Right, and how we have one big kind of overarching database. And inside of that database, we have a table, or we have a series of tables, right? We can have as many tables as we want, and inside of those tables, we have columns, and those columns dictate the types of data that are in each of those columns, right? And then based on, the data that's in those columns, we have rows, which we call records, and each individual row is a record that has a piece of data, a data point, or a datum, if you will, that represents some point of data in each of these columns. So as we're defining a new table, we need to make sure that we are defining all of the columns that go in that table as well. So we're actually making a plan up front about what we're doing. So this is where we're getting into one of these situations where it's a good idea to sit down with a piece of paper, a pencil, and kind of have an idea about what you're wanting to do before you do it. Because I know, okay, I'm going to want to create a table. Creating a table on its own, relatively simple. We're going to have a create table command. So instead of using select here, I know I'm going to create a table. So instead of select, I'm going to start out with create table. That part's simple. We'll have to give that table a name. But then we'll also have to go ahead and declare all of the data, or all of the columns, for the data that's going into this table. Now, it would be nice if that was all we had to do. All right, but before we get into that, just kind of put a pin into that. We'll come back around to that. Let's go ahead and let's come here to our MySQL workbench. We're going to create a table. And we're going to call this table, our champions table. So this is going to be our champions table. So in this champions table, I'm going to have 3 data points, right? I'm going to have an ID number, so we're going to have a champ ID. So I can have some sort of foreign key, right? I'm going to have a team number. That way we can have a relational point, right? So the primary key is going to be the champ ID. The foreign key is going to be the team number. And we're going to have the year that they won it, right? So the year that they became the champions. So the first champ, so on and so forth, right? So champs, so we're going to create a table and we're going to call it champions. And so now we're going to define the different columns that are going to go in there. Now, in MySQL, it is one thing to say that we're going to go ahead and define the columns that are going to go in there. But when I define the columns that are going to go in my table, I am also making my database a promise, which is something that makes this a little bit tricky. Right? That's something that makes this a little bit tricky, is that when I create this table, I'm creating the columns that go into the table, but I'm also making my database a promise, and that is that I am going to put a certain type of data into each of these columns when I load information into the records in this table. These are our MySQL data types, and it is easier for me just to look at them with you all in some documentation. Because as we can see here, there are a lot of them. Right? There are a lot of data types that are in or MySQL, or that MySQL uses. And so when I'm creating a table, I give my table a name. I tell my database, this is going to be my table's name. These are the columns that are going to be in my table. And I'm going to make my database a promise of the specific type of data that I'm going to put into these columns. Now, I can tell you right off the bat, right, that there are some of these that I use more than others, right? Like variable character, varchar. I use it more than a lot of others. Int, INT. I use it more than a lot of others. Float, might use float. Float is just a floating point number, right? Decimal number. Then we have date time, which we looked at a little bit. Date and time, which we looked at a little bit in the previous module. The idea that date and time and year are different data types in MySQL. They're handled just a little bit differently than some other data points in MySQL. So I'm making it a promise that not only am I going to have these columns in this table, but these columns are going to have a certain type of data in them. Right? For example, we said we wanted 3 different columns in our sample query here. Champ ID as sort of a primary key. Team number to use as like a foreign key. And the year. Right? So in this case, we have basically 2 integers, right? Champ ID is going to be an integer. Team number is an integer because in this case they're, team number 1 or team number 2. We can actually maybe even use a different type of data point here, or a different type of data type here in our numeric value. Because we can see something like tiny int, which is a very small integer, something that runs from -128 to 127, or from 0 to 255. If we know that there are only 2 teams and they are called Team 1 and Team 2, and they are represented by integers, even if we wanted to future-proof this database for some point in the future, we might even be able to assume that there won't be any more than 127 teams in our, in our tennis league here. So we might be able to use tiny int there. And then year, well, year is year. We can use a year data type there. That's something that we can deal with, right? And so we're making the promise, right, that not only are we having these columns in there, but these columns are going to get this specific information. While we're here, we can talk about some of these data types, right? We have char, or character, and this is basically just a string, right? In MySQL, when we see char, it is just a fixed length string. Right, and so I can use char to help me with data validation if I know that a string that is going into my database is going to be a certain length every single time. Then I can use char with my fixed size. When I use char, I have to give it a size because it has to have a fixed length. So I have to give it a size parameter. Anything from, it says 0 to 1 to 255, right? But if you have a variable length or a fixed length string with a 0 length, it's nothing, right? Like it's null. So that's kind of useless. So it really needs to be at least 1 character, so it needs to be 1 to 255. But varchar is going to be more useful to us, right? Because it's not just a fixed length string, it's a variable length string. So instead of just having to be a specific length every single time, it can be anything from 0 characters, from null, as long as we, don't declare it as a not null column, to the maximum column length of characters that we defined, which can go up to 65,535. Which I do think is kind of interesting because we see a lot of instances where, a lot of these are sort of our 2 to the nth values, but there are a couple instances where we see some numbers that are not 2 to the nth values, which are kind of interesting when we're dealing with these data types. But that's what separates variable character from character in terms of our SQL data types, right? Because character, it has to be the exact number of characters that were specified when you created the table. So if I create the table and I say, okay, this is a char column size 8, and you try to put 9 characters in that column in a record, error. Not going to let you do it. Try to put 7 characters in that column in a record, error. Not going to let you do it. It's only going to accept the data if you keep your promise and you enter an exactly 8 character length string. Variable character, on the other hand, if you enter 9 and you promised 8, that's too many, right? So it'll error there. But if you enter 8 or less, it'll be just fine. So 8's fine, 7's fine, 6's fine, so on and so forth. Binary, variable binary, tiny blob. Blob standing for binary large object, which is kind of interesting because it uses the object for that there. Kind of interesting. Don't really want to get into it for, kind of where we're starting out here at an entry level. Tiny text, regular size blob, medium text, medium blob, long text, long blob. Right? Like you could see instances here where okay, if I have a WordPress site, I'm either going to use a long blob or a long text to hold a blog post, for example, right, in my database. But if I am, for example, or where am I going with this? But there was where I was going. For most applications, it's probably going to be some kind of variable character or varchar if I'm using some sort of string data type in a database. Similar sort of situation with numeric values. Right, first we have a bit value. Bit, tiny int, bool, boolean, small int, medium int, int. Int and integer are basically the same thing. It's just, you can spell it out or just use the abbreviation. Big int, right? And you could just use different sized values there. A reason why we might use different sized values would be for one, memory management. Right, for example, if any of you have taken Java yet, some of you might have. I don't know if I doubt very many of you have. Maybe none of you have. Don't quite remember. But we talk about the idea of float versus double when we are talking about floating point numbers. And there's a similar thing for integer, right? Where you can use an integer, you can use a large integer. And it gives you a lot more precision to use a double than a float, but it also, takes up more memory, so it all, deals with memory management and how things work in terms of all of that. We can even see here that we also are dealing with floats and doubles here. And then finally we have our date and time data types. You saw date a little bit in the previous module, in module 3. But we also have one for a timestamp, which uses the UTC timestamp format, which is pretty interesting to kind of look up on its own. There's also one for time and one for year. We'll be using year in our demo here that we'll be working on in just a moment. But there are all sorts of different data types here, and I really suggest that you all kind of go through and just kind of read about these. I believe I have all of this linked out in your module as well. Right? It's gonna help you to kind of have this as reference while you're working on things, just so you kind of understand, okay, like, if I do this, then I put that there, and I understand, like, all right, I can work with that. So we know we're going to create our table. We're going to call it champions. And the next thing that we're going to want to do is we're going to want to add some parentheses. Right? We said that when we add parentheses in MySQL, these are things that we want to do together. And so we want to make sure that we are creating all of our columns together. Right? So we have our 3 columns that we want to create together. We want to create our champ ID column. We want to create our team number column. And we want to create our year column. So I'm going to create my champ ID column. Right? I'm going to put in my column name. Hit a space. I'm going to add my data type here, which I think we'll make this one just an int. And then we'll put a comma here. And if we don't put a value in parentheses after our int, it's just going to assume, basically the max amount can be put into there, so it's fine. The next one is our team number column, so that's team number. And I think we said we wanted to try out tinyInt there, just to see that, since we only know of 2 teams, 1 and 2. And that will take values up to like 127. Right, so there's that. And we want a year column, which will take our year data type. And just so we don't confuse the name of the column with the data type, maybe we should call this win year with our year data type. Now, we could be done here. We're not, but we could be, because there are some ways that we can make this better, right? But this is our bare bones for what we need to create a table, right? We have our create table in place of our select. We have a table name, and we have our columns defined with the data types that we want to put in them. There are some other things that we can do here to make this a little bit better. one of the first things that we can do here is to check to see if this table already exists. Because if it already exists, we don't want to try to create the table again. Right, so we can add an if not exists. Exists. To the front like that. I believe this is the proper syntax. If I remember correctly. Maybe not. Let me just look at my notes real quick. I've abandoned my notes. I've abandoned my notes to start to look at other stuff. Yes, I did. I want to put it after create table. If not exists. I want to put it there instead. Of course, not at the beginning, at the end. Or not at the end, after create table. So create table, if not exists, champions. So I want to create the table if it doesn't exist. Right, that's what happens when you try to write too many programming languages in the same semester, right? You get confused about where the if goes. Does it go at the beginning? Does it go in the middle? I'm doing conditionals in the 215 class this afternoon for JavaScript. JavaScript conditionals definitely go at the beginning of the statement. So create table if not exist champions. Apply these columns to it. A champ ID of integer, a team number of tinyint, and a win year of year. I also might want to make sure that you fill in every single column every single time. So it might be smart of me to add a not null to each of these columns. That way when you go to add data to each of these columns, it makes sure you add something to each of the columns that has a not null modifier onto it. It's basically like a required field if I was building a form. So it turns this into a required field that has to have something populated into it when you are adding a record. So in this case, if I need a champ ID, I need a team number, and I need a win year, may as well put them all in there. Another thing that I might also want to do is identify the primary key. And so I can identify the primary key relatively easily. By simply adding it as an additional part of our statement here. So I'm going to add a comma. I'm going to add the words primary key. And in parentheses, I'm going to add the column of these three columns, which is my primary key, in which case it is the champ ID. Champ ID. So now if I run this, we see we don't get anything here. And that's going to be one of the tough things that we want to kind of battle coming off of this, right? Because why doesn't it show me anything? Well, it does. It doesn't show me anything because I didn't write a query that sends me back information. I wrote a query that created something in my database. It created a new table. If I look in my tables here, and I actually do I'm going to cut this for a minute. I'm going to bring it back. If I run a show tables command now, I can see that I now have a champions table added to my tables in my tennis database that wasn't there previously. And if I run a describe command, on that champions table, which is that the command? No, I don't know why I put that. That doesn't go in. That doesn't go in parentheses. What am I thinking? That doesn't go in parentheses. I just say describe champions. I can see exactly what I just entered in using that query. Right? Champ ID is an integer type. It's not null. Primary. Right? It's identified as the primary key. Team number is a tiny int. It's not null. Not the primary key. Win year is a year type. It is not null. It is not the primary key. Right? And so those are the results that we get after running this. And since we added that if not exists, it's not going to do it again. Like, it's not going to give me some kind of thing. All right? And if we notice down here where it errored, it didn't error. Right? This is an error. X in a red circle. It threw me this warning this time. So it didn't error. It just threw me a warning and let me know that the table already exists. So that's one of the great things about using the if not exists there. So now we have this new table. Create table, if not exists, champions. So if it doesn't, so we're going to create the table. If it doesn't already exist, we're going to call it champions. We're going to give it a champ. We're going to say, okay, give me a column called champ ID. I'm going to put integers in that column. I'm always going to put integers in that column. I'm never going to leave that column empty. We're going to make a column called team number. That's going to be a tiny int. That's going to be a small number. It's going to be between 0 and 127. I'm always going to put integers in that column. I'm never going to leave it empty. And then the win year is going to be a year. I am never going to leave that empty. And the primary key for this table is going to be my champion ID. Which is great. And so, with that being said, let me check where we are at in terms of slides. I believe that's all we have for today. Yes, that gets us to slide 10 in our slide deck of 30. And so I also checked my calendar briefly just to see. It looks like next week's will be pre-recorded. There is an event on campus next week that is a campus-wide professional development, which means I will be otherwise occupied next Monday. So I am afraid that we will not be able to have our regular live class next Monday, so I will be posting some previously recorded material next Monday instead of our usual live material, but I will be back with live material the week after. We'll turn the music back on, hang out and chat for just a couple of minutes, just in case anybody who was here with me live has any questions. But again, that's all that I have for you for now. Thank you for watching, and we'll see you next time.